and temperature.
Okay, concentration and temperature, that's correct. Then also, a question here says, explain briefly how a catalyst increases the rate of a chemical reaction. Explain briefly how a catalyst increases the rate of a chemical reaction. These are actually theory questions in WAEC.
Oh.
So, what do you think will be the answer to such a question if the student is faced with such, or how will you advise students to go about answering this? Explain briefly how a catalyst increases the rate of a chemical reaction. Are you there?
Yes, I'm here.
Okay. So since they said explain briefly, there's no need writing long story. Always tell your students a catalyst affects the rate of a chemical reaction by lowering the activation energy of the reacting system, or a catalyst affects the rate of a chemical reaction by creating an alternative pathway for the chemical reaction to occur. That will just be the answer, as simple as that. Is that it?
Right, thank you.
Okay, you're welcome. Now let's also look at another question here. Maybe you might write this one down. Are you ready?
Yes, I'm ready.
Okay. Sketch and label an energy profile diagram. Sketch and label an energy profile diagram to show the effects of the presence. Sketch and label an energy profile diagram to show the effects of presence of, like this, of PT RH. The effects of presence of PT/RH on the reaction represented by the following equation. On the reaction represented by the following equation. Is that taken?
Yes.
Okay, so this is the equation for that particular reaction. For NH3, that is for ammonia, 5 moles of oxygen gas gives you 6 moles of water and 4 moles of nitrogen 2 oxide, NO2. While enthalpy change for the reaction is minus 90 kilojoules per mole. Did you get the question?
Yes. Sorry, was that part of the question?
Yes, this is part of the equation because it said
Okay.
sketch and label the energy profile diagram to show the effect of presence of PT RH on the reaction represented by the following equation. So this is the equation for the reaction.
Okay. Yeah.
Are we ready?
Yes.
Okay, so in such a question, what's the first thing to always do? Always tell your students they should check out for the enthalpy change of the reaction.
Okay.
In this equation, the enthalpy change is what? This when we say enthalpy change, this is what we mean by enthalpy change triangle H. I'll soon get there very soon. So enthalpy change is your triangle H there, and the value is what?
Was there a value attached to it? Sorry.
Yes, that is triangle H.
I'm not saying that thing. I'm not saying it well.
Okay, let me just read it out. This is 4NH3
Okay.
plus 5O2.
Okay.
Give you, that is your arrow, 6H2O.
Okay.
Plus 4NO.
Okay, then the delta H.
Then delta H equals to minus 90 kilojoules per mole.
Okay. Thank you.
Okay, welcome. So, like I said, since we were asked to sketch the energy profile diagram, and then remember they said in the presence of PTRH. So that PTRH ought to be up here like this. That PTRH
Okay.
means platinum rhodium catalyst, which means that in this reaction, there is a presence of a catalyst. Then the next thing to always watch out for is the enthalpy change, which is your delta H. Is it a negative value or a positive value? What can you see here?
It's negative.
Okay, so if it's negative, what can we say about the entire reaction? The reaction will be an exothermic reaction
Yes.
because it's negative. And once it's positive, it is endothermic. We'll talk more on that one in the next few minutes. So, but since we're asked to draw the energy profile diagram, now it has been established that the reaction is an exothermic reaction. Also, there's a presence of a catalyst. So what the examiner wants to see is this. You will draw the energy profile diagram like this. What do we write under here? Reaction pathway
Reaction.
or reaction coordinates. Anyone we want to write is correct. Up here is energy.
Energy.
Now, because the reaction is exothermic, it should be like this.
Okay.
Then we know this side is always reactant, but I will not write reactant because an equation was given. So what is the reactant in that equation? Because I've cleaned it. Can you help me out again?
Okay, the 4NH3
So I write here 4NH3 plus
plus S plus 5O2.
okay, 5O2. Then on this side, which is my reactant, I will write, sorry, product rather.
Yes.
That will be what now?
6H2
6H2O plus
4NO.
NO. Then we will label your diagram correctly. From here, down here is enthalpy change, that is triangle H, which is given as minus 90 kilojoules per mole. Are you with me?
Yes.
Then up here is TS, your activated complex. Then also here is EA, activation energy. You do get that?
Yes.
Okay. Now, one very important thing which you have not done, the question was, let me just go through that question again. Sketch and label an energy profile diagram to show the effect of presence of PTHT, which has not been shown from the diagram. So you will now draw a broken line. That PTRH is simply the presence of a catalyst. So, and that will be your answer. Then you can now write here uncatalyzed. And this other one will be catalyzed. In brackets, PTRH. Is that okay?
Yes.
That's all. Any question?
No.
Okay, thank you very much. So let us look at all these ones were just what we treated the last time. I have more, but because of time, let's look at the content for today. Because of the lesson, we can chip in those other questions.
Okay.
Can I clean the board?
Yes, you can.
Okay, so you can just write a sub-heading there. Let's start from energy changes in chemical reaction. That's what we are looking at today. Energy changes in chemical reaction. Energy changes in chemical reaction. Let's start from under that one. You can write definition of terms. Definition of terms. Are you ready? So in terms of the terms, you have so many. You can start with the first one, enthalpy. Don't need to write them. I'm just going to list them, but we'll move on gradually. Are you with me?
Yes, I'm with you.
Okay. So these are some of the terms we'll be looking at. So the first one is enthalpy. What is enthalpy? Hello? Madam Agatha. Enthalpy is simply defined as the total heat content of a system. Enthalpy is defined as the total heat content, HEAT, heat content of a system or of the system. Is that okay? I need response, Madam Esther. You get that?
Yes. Yes.
Okay. You got that? Let's also move on. All right. It is designated by the symbol H. Capital letter H is enthalpy, by the symbol for enthalpy. It is designated by the symbol H and is changed as triangle H. So H is the symbol. Why this is the change of in enthalpy, that is triangle H. Any question?
No, no question.
Okay. Then we can now write mathematically, enthalpy change is equals to heat product minus heat of reactant. That is the formula for calculating enthalpy change. Heat product minus heat of reactant, or you can put in front of it summation, because sometimes it could be more than one, and then summation. That is summation of the heat product of minus summation of heat of reactant.
Okay.
And then let's write note. One, if enthalpy change, that is triangle H, is negative, the reaction is exothermic. Is that okay?
Yes.
Because heat content of reactant is higher than product. Because the heat content of the reactant is higher than the product. That's the first one. Then number two will be the opposite of everything we just said now.
That E delta H is positive.
Yes. The reaction
Thermic.
endothermic, because heat content of product is higher than reactant. Is that okay?
Yes.
Okay, so let's look at a few examples, maybe one or two examples under this enthalpy, and we'll move on to the next thing. Example one. The standard enthalpies of formation. The standard enthalpies of formation of CO2. The standard enthalpies of formation of CO2 bracket gas, H2O bracket gas, and CO in bracket gas as well. Are you there?
Yes.
In kilojoules per mole. In kilojoules per mole are minus 394, minus 394, minus 292, right? Okay, 394 is 242, sorry, minus 242, and minus 110, and minus 110, respectively. Respectively, full stop. What is the standard enthalpy change of what is the standard enthalpy change for the reaction? What is the standard enthalpy change for the reaction? This is the equation that you write: CO gas plus H2O gas to give me CO2 gas plus H2 gas. So that is the equation for the reaction.
Sorry, is it CO2? The first one is okay, CO plus H2O.
Yes, CO plus H2O will give you CO2
Okay.
plus H2, all gaseous states. And we are asked to calculate what is the standard enthalpy change for the reaction.
Okay.
I think it's simple now. All right. Okay. The formula is enthalpy change equals to summation of each product minus summation of each reactant.
Yes.
That's the formula. And if you check the question, we are given the values for CO2, H2O, and CO to be minus 394, that is for CO2. See, they said respectively, so this is for this. H2O is 2 minus 242, and CO, which is your carbon 2 oxide, is minus 110.
Okay.
Then, if you check your equation, we have CO, we have H2O, we have CO2, but we don't have H2, right?
Yes.
And the value for H2 was not given, right?
Yes.
Good. So your student might begin to wonder, auntie, uncle, why is there no H2 there? Let them know that the standard enthalpy change for a free element is always 0. Hence, there was no value for H2.
The standard, sorry.
The standard enthalpy change for a free element is always 0. This is a compound, CO2, or CO is a compound, H2O is a compound, CO is a compound. This is an element. So hence, there's no value for H2. That's the gaseous there. It's always 0. Is that taken out?
Yes.
I'm going so a little bit in depth because even the skin that we have is so watery. These ones are not in the skin. But it's,
Not in it.
but it's better when teaching the students, teach them these things because why to set it. So, and there are some other things also not in the skin which I will soon discuss as we move on. Please incorporate it into teaching as we move on. It's for those, if you have not been teaching this aspect for a very long time, or you have not been privileged to be teaching it, some persons will just go with the skin because it's not there, they will not teach it. But it's important the students know it, so that once you are done with a particular topic, you know you are done with it extensively. Okay, let's come back now. What is the products that we have here based on the equation?
The products.
Yes. Our product of the equation is CO2 and H2, right?
Yes.
And remember, I just said H2 does not have value. So your formula becomes, what is the value for CO2 as given in the question?
Is minus 394.
You put it here, minus 394 minus. Remember, this is summation. Why they put this one here? Because the reactants will be more than 1. So you add all of them together. So I'm going to open a bracket now. We have 2 reactants. We have CO and we have H2O. The value for CO is what?
Is minus 110.
I'll write it there, minus 110 plus, because summation means you are adding it up. Then
plus minus 242.
open a bracket, minus 242. And do it like this. Do you understand it?
Yes.
Okay. We move on. Plus times minus, we give me minus. So I will now have minus 394 minus 110 minus 242. If you solve what is inside the bracket first, that will give you minus 394 minus open bracket again. That will give me minus 352. Any question?
No, no question.
Okay. Plus times minus will give me plus. So that will give me minus
Plus.
394 plus 352. And my final answer now becomes minus, because this is greater than this, that should be minus 42, if I'm right, yes. Minus 42 unit is kilojoules per mole. So that is the answer for that question. Did you understand it, madam?
Yes, and then.
Okay, so they can go further and ask the students maybe to now draw the energy profile diagram for this reaction.
Okay.
So because the value is negative, that means the reaction is exothermic reaction.
Yes.
So that means they are now to draw energy profile diagram for the exothermic reaction. We'll get there. So let me just leave this one now first. So example 2. Example 2. If I end this class and you are only the one present, that means after now, I will just end the retreat, because since I see I'm only suffering myself, only 2 of us, and it's not encouraging. Right? Or don't you think so?
I don't know what to say right now, honestly.
Because for each session I do, I spend nothing less than 3 megabytes, and 3 megabytes in 2 days, that's 6 megabytes. You know how data is expensive these days. But then
Yeah.
it looks as if I'm the one that needs the information more, but I actually don't need it more than what. It's all good. Let's move on. Example 2. Are you ready?
Yes, I'm ready.
Okay, that example started with an equation. So that is 2CO plus O2 will give me 2CO2. 2CO plus O2 give me 2CO2. All gaseous states.
Okay.
Given that, then we can now write, given that, write it like this, enthalpy change in bracket CO is or equals to minus 110.4 kilojoules per mole. That's okay?
Yes.
And again, enthalpy change in bracket CO2 equals to minus 393.0 kilojoules, minus 393.0 kilojoules per mole. Full stop. Calculate the enthalpy change or the energy change for the reaction above. Calculate the energy change for the reaction above. Is that okay?
Yes.
Okay. So the formula again is what? Enthalpy change equals to summation of
Product.
You can write this in full, each product minus summation of each reactant. Are you with me?
Yes.
Okay. So there's no value for O2. Why?
Because it's a free element.
Okay, so it's 0. So what is our product?
Our product is CO2
Okay, and what is the value for CO2?
minus 393.0.
Okay, what is the number of moles of CO2 in the equation?
2.
So that would be 2, open bracket, minus 393. The other one we did, this equation, the number of moles were 1 or 2. That's why there was no need to multiply. So let the student know that. Then minus our reactant is also 2. There's a number of moles, bracket, minus 110.4.
Okay.
Then you open your bracket by multiplying. So if you multiply this, that will give me minus 786. So this is minus 786 minus brackets minus 220.8. If I do that right, 220.8. Are you with me?
Yes, I'm too.
Okay. Then plus times, sorry, minus times minus, you give me plus. So that becomes what?
Minus 786 plus
Plus
220.8.
0.8. If you do that, it should give you a negative value of minus 656.2. Minus, sorry, 565.2 kilojoules per mole. Any question?
No.
Okay. I have one here, but let me, I think I have just 7 minutes to go for this first session. So I will dictate this question. You will solve it and tell me the answer before the 7 minutes goes off. So we can continue when we come back again in the next. We'll come back. Once this goes off, we'll come back immediately to continue. Are you ready?
Yeah.
Okay, so for this particular question, again, it started with an equation. The equation is Fe2O3. Fe2O3, that is iron 3 oxide. Fe2O3. Are you there?
Yes.
Plus 2Al. Fe2O3 plus 2Al aluminium will give me Al2O3. Al2O3 plus Fe. Put 2 in front of the Fe, that is iron like this, to Fe. Are you ready now?
Yes.
Okay, let's go. If the heat of formation of that is this one now, Al2O3. If the heat of formation of Al2O3 and Fe2O3 are,
And sorry, and what?
and that is Al2O3 and Fe2O3, that is this and this,
Okay.
are minus 1670 minus 1670, that is 1670 kilojoules per mole, and minus 822 kilojoules per mole, respectively. Sorry?
Minus 8.
The first one is minus 1670.
Yes.
And minus 822 kilojoules per mole, respectively. The enthalpy change in kJ for the reaction is question mark. The enthalpy change in kilojoules for the reaction is question mark. Take it?
Yes.
Okay, so you can start solving now. Sorry, Mr. Peter, what you are saying something?
Yes, I didn't get the question clearly. That's the problem.
Okay, which part exactly?
I'm reading the question down, but that's yeah.
Okay, let me just come again with the question. This is the equation first of all. Can you
I can hear you.
Can you see the equation? Can you see the equation? Mr. Peter, can you hear me? Seems your network is not friendly. Are you true? And Mess, are you done?
Okay. I'm coming, sorry.
All right. Mr. Peter, can you hear
Yes,
me?
it's like network ran out of.
Can you hear me now?
I can hear you.
Okay, I said the equation is on the board. Can you see the equation?
Yes, I've written that already.
Okay, so the question is, if the heat of formation
Okay.
of Al2O3,
Al2O3.
yes, that is this, and Fe
Yes.
and Fe2O3, that is this on the right hand, and Fe2O3 are minus 1670, that is for this, and minus 822. You can see kilojoules in front of them, kilojoules per mole, and now put respectively. Calculate the enthalpy change in kilojoules for the reaction.
Okay.
And that's just the question. So
I think my answer is minus 848 kilojoule per mole.
okay.
Is it correct?
Okay, now are you doubting yourself? Now let me give you the options so that you know.
Okay.
Option A is plus 2492. Plus 2492. Option B is plus 848. Option C is minus 848. And option D is minus 2492.
So option C is for me, minus 848.
Okay, why not B?
Plus.
Okay, but the answer is actually C anyway. Yeah. You see, it's very simple.
So it's a good one.
So
Yeah.
teach the students, let them know this aspect. Very important. You know, it's sometimes it comes out in JAM, most especially. Very few questions in WAEC, but if it's WAEC, you mostly see it in the theory aspect. So we are left with just a minute to go. So let me just allow the time run down. I will come back to continue with the next part quickly. Yeah. So,
Okay.
Mr. Peter, can you hear me?
Yeah, I can hear you.
Okay, so we'll come back to start off with enthalpy change and various entropy and types of enthalpy changes. And if possible, we can now look at chemical equilibrium and then some other aspects in the next 45 minutes once we come back again. So thank you very much for this. So you can just use this 1 minute, stretch your legs, put 1 or 2 chin chin in your mouth, take some fluid, and then we'll come back again.
Okay.